Hi there, my name is Kevin Newton, and I am here to talk to you today about the yet another Ruby Parser project, otherwise known as YARP, that I've been working on at Shopify. I've been working on this project for about 6 months with a couple goals to create a new parser for the Ruby language across implementations and tools, and generally unify the ecosystem around one effort to expand the parser. I started this project about 6 months ago in earnest at Shopify, but in reality, it's been about the last 5 years. I started working on this project back when I started working on Prettier, which was a formatter for Ruby. Back then, I was using Ripper's output to build the AST and then format it from there using TypeScript. Eventually, this evolved into Syntax Tree, which was a new project that was built entirely in Ruby, which was effectively a port of the TypeScript piece of it, such that we had an object layer on top of the Ripper AST. But something that's always been difficult about it has been using Ripper. Ripper's interface has been very difficult to use. And there are a lot of shortcomings with using that kind of parser. Everything is specifically tied to CRuby, and there are numerous difficulties with using Ripper's interface that I've gone into in previous talks. I really liked this comic. I found it when I was researching for this talk. In summary, it says, I pray for the strength to change what I can, the inability to accept what I can't, and the incapacity to tell the difference. I felt a lot like this when I was talking to my manager at Shopify about rebuilding the Ruby parser, because it seemed like an insurmountable task. But that being said, in the last 6 months, we have gotten to the point where we can parse 100% of Shopify, GitHub, Ruby, the top 100 gems by download on rubygems.org. At this point, we have an experimental fork of CRuby that is using the new parser. It has been merged into Truffle Ruby, and they are actively working on making it their default parser. And there's an experimental branch in JRuby. So I would say that we have come quite a long way, and I'm very excited to talk to you today about the progress we've made and what it looks like. So first, we're going to talk about the motivations behind building a new parser. Why would we even attempt to create this kind of thing? These motivations boil down to three things: error tolerance, which is the idea of allowing the parser to continue parsing even in the event of a syntax error; portability, which is the idea of allowing people and other tools to use this project outside of just CRuby; and maintainability, kind of an arbitrary subjective measure of the ability to change, delete, or update the existing parser. Then we'll get into the development of the new parser and what that has looked like. Specifically, we'll talk about the challenges of the Ruby grammar and how we've kind of gotten around some of those things. Finally, we'll talk about the path forward. This involves the adoption of the YARP project, and as well as future work and the direction that it's going forward. So the first of these topics is error tolerance. Error tolerance is something that we could talk about for an entire talk or many talks. It's something people have built entire careers off of. To give you just a small taste of it, we can actually look at IRB. IRB has error tolerance baked in as at least a bit. If you look at this example, firing up IRB, we say foo plus bar plus baz, but we inserted some garbage characters. IRB is actually able to recover from that and notice that baz is still an identifier, but it does say that there's a syntax error. So this is actually error tolerance, and the way that it does this is it uses Ripper and tokenizes the input and kind of drops out garbage tokens until it finds something it can understand. Another example in the Ruby code base is actually in Rust. If you use VS Code or really any other editor that hooks up to the Rust Analyzer extension, you can see that it can handle a lot of errors. You might not be able to see it on the slide, but specifically there's an extra pipe on line 21 there that is able to recover from and continue parsing the rest of the file. So really with IDEs, this is very important because IDEs have tooling available like type checkers and refactor tools, any kind of things on hover, and they need to be able to maintain that state between updates. So if a syntax error happens on line 2, but the entire rest of the 1,000-line file doesn't have any other errors, it doesn't want to just discard the rest of the AST. It wants to keep it around and just make incremental updates. So in this case, Rust and specifically the Rust Analyzer project is able to recover from that error, which really drastically helps development speed and helps while you're typing, and you're only usually changing one spot in the file at a time. So specifically with the YARP project, we've implemented some error tolerance. We have plans for much more. At the most basic level, what we can do is we can automatically insert tokens. What this means is, for example, if you have the beginning of a class declaration, you say class foo, and you don't have the end token, we can automatically detect that and insert the end token for you to make the rest of the tree work. It will create a missing token and add an error to the list of errors, so you will still get a syntax error, but tools like IDEs or linters or formatters or any other kind of static analysis tools will be able to continue to maintain the rest of the tree without trashing it. We can also insert nodes into expected places within the tree. For example, if you were to have 1+ and then no other statement, we would insert a missing node into the tree. So you would still get a fully formed tree. There would just be an error listed on it. And this is kind of the most fundamental point. Whenever YARP parses a Ruby input, it never crashes. That is never something that it does. Whenever YARP is parsing a tree, it will always return at least one tree. The tree might just be the root node, but it will always return something. In addition, it will return a list of errors and their offsets from the beginning of the file. So what this looks like, this is a very small example from actually a couple months ago. When it's parsing, we have a VS Code extension where it's using YARP to parse the file, and you can see a+ and then brace. So YARP is seeing this as the beginning of a hash literal, and it's saying we don't see a key, we don't see a delimiter, we don't see a value, we don't see a closing. But it can continue parsing on past that because it'll insert those 4 errors and say, okay, now we know where we are. We're going to assume that we just missed the closing brace, and we can continue parsing as if it were there. The next important piece of this is context-based recovery. This is something that was built when Microsoft needed to build a new PHP parser for VS Code. And so we based this on their papers from that. This looks like this example. If you look at this code, you can see that we're multiple levels deep into the bar method definition inside the foo class, inside of a block, inside of an addition and a multiplication. And what that would look like is many levels deep in the AST. You have a class node and the statements node, def, call, self, block, self, multiple levels. And at this point, you're in the arguments to the baz method there, to the multiplication method there. And we're looking for an argument to parse. And it's very difficult to find because there is nothing there. There's just a new line and then the end keyword. So what do? One thing that we can do, and what we do with YARP, is keep a stack of contexts around. So whenever we enter into a node that is expecting a closing delimiter, we'll push onto a stack a specific context. In the case of the class node, we push on the class context, which expects either the end keyword or, funny enough, the rescue, ensure, or else keywords. When we enter into a def node, we push on the same ones. And when we enter into the block node, in this case, it's using a brace block, so we push on the closing brace. We expect the closing brace. Now, at this point, when we're after the multiplication here, we can see that actually we walk up the stack of context and we see the end keyword and we say, oh, the end keyword actually closes a parent context. In this case, we're not just going to drop the end keyword and continue parsing until we find something that makes sense. Instead, we're going to say, because we know that this closes a parent context, we will instead insert a missing node into the tree. In this case, after the multiplication, we will insert a missing token for the missing brace, and then we will return the entire tree. So in this case, we're able to smartly see that the end keyword should close that context and build the tree around it. So that's context-based recovery, and that is kind of the first pass at error recovery that we have, and error tolerance that we have within the YARP project. So the next part about this I want to talk about is portability. As I've said before, portability is the ability to use this parser outside of just the CRuby project. It turns out that this is a very difficult problem, and because CRuby's parser has not been able to be used, there's been so many different efforts around the ecosystem to build other Ruby parsers in order to still be able to run Ruby. You can see all the different runtimes. You can see all the different tooling. These are a small subset of the parsers that have been written. These are actually only the ones that are still maintained. There are actually dozens more. You can see on this website I linked from a previous RubyKaigi talk. These parsers are still actively maintained. And so every time there's a change, for instance, pattern matching from Ruby 2.7, all of these other parsers had to go and update, which makes it very, very difficult to stay up to date and to stay in sync with CRuby. What that means is that there's a ton of community effort going into maintaining all of these parsers when all of that energy could instead be focused on the runtimes and the things that make each of these tools and runtimes great. So how do we solve this? It's interesting because all of these projects have given birth to tons and tons of different projects themselves that are reliant on these individual parsers. For instance, my own project Syntax Tree runs on Ripper, Ruby Format, Rufo, Syntax Suggest, and Ruby LSP. They all run on Ripper at some point. There's the parser gem projects like RubyKaigi, Standard, Unparser, Ruby Next, and to a certain extent Solargraph and Steep. Then there's the Ruby Parser Gem, the Seattle RB one that runs Debride, Flay, Flog, Ruby Next, and then Sorbet has its own parser entirely. So there's just so much fracture in the ecosystem that we can fix by having one standard parser. So how do we achieve this? We achieve this first and foremost by having no reliance on any CRuby internals. We don't link against CRuby headers. We don't use things like value, ID, ST-table, any of the real internal CRuby structures we don't use. We also have no reliance on any external packages or generators. This is a handwritten recursive descent parser. We are not using some kind of Bison port or any kind of Antler or parser combinators or any other kind of generator. And we have severely limited using any kind of external tooling in order to make it more easily embeddable in other projects. Having this standardized parser allows us to have a lot of shared logic. Not only are we parsing the AST, we can also do things, and we are doing things like unescaping strings. For example, \n, the new line character, when you parse something with YARP, you get both the range in the internal source file of the string, but you also get the new line character inserted correctly into the unescaped version of the string. We also have the pack API, pack and unpack for array and string. These things are the API to parse that is actually its own mini DSL, and we actually have a parser for that inside of YARP that can be shared across runtimes. And the way that we share this thing is something called the serialization API, which I'll go into very quickly here. So this is actually code pulled directly from Truffle Ruby when they integrated the YARP parser. This was an early commit. It's changed a little bit since, but you can see that they're pulling in yarp.h, which is our top-level header file. And I'll highlight just the important bits here. This is how you use YARP from the C level, where we initialize a new YARP buffer. We call parse serialize with a char star and the size of the char star and a pointer to our buffer. And what that does is parses the AST and then dumps the AST into a serialized format where the root node is always first after a header, and then it goes in a depth first walk to find all of the children. So you can actually parse it into an AST structure that can be deserialized in a different language entirely. And then you free the buffer at the end. So using this API, Truffle Ruby and JRuby can use the same parser and pull in the same project, but they can deserialize into their own language, and they don't have to update any grammar files. They don't have to change, rule production actions into Java. They don't have to do any of that very difficult maintainability issues. They don't have to suffer through that. Instead, they can just write in Java and continue to work on their runtimes and what makes their runtime special. Speaking of, maintainability was the final motivation that I wanted to talk about. Maintainability is a very broad subject with a lot of different it's very difficult to measure. It encompasses things like readability, understandability, ease of contribution, ease of change, documentation, test suites. All of these things come together to form what we think of as maintainability, and they're all very subjective. But that being said, I wanted to talk about that very quickly to say, is YARP more maintainable? I believe it is, and our team believes it is, because for a lot of reasons. One is it's very, very easy to change. YARP is a handwritten recursive descent parser. If you want to make a change to a specific way that one particular node is parsed, you can go in and make that change very easily. That makes it so that updating it and adding syntax is very, very easy. And because it is easy, it makes it so that hopefully it's more maintainable going forward. It's very, very well documented. We have a test suite for every node, and because of the way that it is built as a handwritten parser, you can add breakpoints into any point in the C file and very quickly get to that point without having to mess around with generating anything. The other question I want to ask is, can we make YARP more maintainable? And that really comes down to contributions. Our team, though we have been working on this for a while, is still relatively small. And the way that you make something more maintainable is by having more eyes on it. So please come help contribute, come take a look at the code. If there is something that is confusing or something that is difficult or something that you do not feel is maintainable, I would love to have your input, because the more eyes we get on it and the more contributions we receive, the more we can make this the best possible parser going forward for CRuby. So I want to take a minute here and talk about some of the challenges that we faced. CRuby or Ruby in general is a very, very expressive grammar and has lots and lots of different features that are supported implicitly and explicitly. So probably the biggest challenge of all at the very beginning is just grammar ambiguity. What does it mean when you have certain operators, keywords, identifiers in certain places? And they can mean very different things depending on the context that you're in. You can have a triple dot operator that can mean argument forwarding, or it can also mean a range, and that range can be beginless or endless. And because these things are reused in many different ways, it makes it so that you have to have a lot of context and state that you store around your parser that we end up storing in the lexer in order to generate the correct tokens in the correct order. So this also gets into unary versus binary operators and spaces. For instance, if you have the plus operator, that can actually be a unary plus or a binary plus. It can apply just to the right-hand side, or it can join an expression. And sometimes this has to do with whether or not there's a space in between the operator and the thing it's operating on, which can be very confusing for the end user, but it can also be way more confusing for the implementer of a parser. The do keyword is also very complex in Ruby. You can find a do keyword to delimit a block. It can delimit the body of a loop, like while, until, or for. And it can also be used in a couple other contexts. Because of this, you have to keep a lot of specializations around of the do keyword. We have various stacks that track where things are being found and how far into a list you are in order to determine if a do keyword is a do on a loop predicate or it's a do on a block. The next is new lines, comments, and semicolons. All of these can be termed as terminators for expressions, but it very, very, very much depends on the context that you're in. That context can be if you are at the end of an expression, then a new line basically means to end the expression there, but then any subsequent new lines are completely ignored because they're not functioning in some capacity that the parser would need. Comments function similarly, semicolons function similarly, but for instance, if you're inside of a keyword argument, then you need to be careful because sometimes they don't actually mean to end the expression. They can just be used to delimit the keyword versus the value. Local variables and method calls were very difficult to implement. Local variables can become method calls if you pass arguments to them or if you pass blocks to them. Method calls can also become local variables if you find commas to indicate multiple assignment or if you find equal signs to indicate regular assignment. As I mentioned about the context earlier, it matters very much to determine if something is a local variable versus a method call if there is a local variable already introduced in that scope, which makes it very difficult because local variables can be introduced in scopes in a couple ways. You can have the regular assignment. You can also have argument capturing in pattern matching. You can also have regular expression named capture groups introduce local variables. And this last one was a big sticking point because the way that it works in CRuby is it uses Onigmo to determine the local variables from the named capture groups. We obviously didn't want to link against that. So in order to build this correctly, we actually ended up building our own regular expression parser in addition to the other parser in order to parse out the named capture groups to correctly introduce the local variables. Finally, we have encoding. Encoding is not so difficult, but it did take quite a bit of consideration because identifiers in CRuby are locale specific. So we added support for, I think it was a little over a dozen encodings by default, and we have capacity to add more if we need to in order to correctly parse identifiers depending on the frozen string literal comment that you place at the top of the file. So the last piece of this presentation is talking about adoption and what that would look like. The first step would be a gem release to Ruby gems in order for people to use this in their own projects and to try it out. At this point, we're still bug fixing, so this is kind of a critical step to allow people to test it against closed source code bases and give us feedback in case they find errors that we couldn't find. The next step is we have a fork of CRuby, and we are working on, at this point, using the parser. The thing is, we have compatibility one-to-one with the Lexer, but we don't have the same AST. We've tried to clean up the AST and make it as user-friendly as possible. But what that means is that in order to truly get this adopted into CRuby, we really need to take our AST and compile it into URF bytecode sequences in order to compare one-to-one and make sure that it's compiling the right way. So we have begun work on compiling it now, and that work is ongoing. JRuby is continuing to explore using this and converting it into their IR. Truffle Ruby has already merged it, and they are actively working on converting it into their main parser. We also are looking at other runtimes and tools. We've had conversations with the team at Stripe about sorbet, and we'll hopefully continue to have that conversation. Personally, I'm going to be updating syntax tree to use this project as its main parser as opposed to Ripper, because I've already found quite a significant speed difference, which on the order of 2x to make syntax tree quite a bit faster. So I'm very excited about that. There are a lot of other tools as well that could benefit from this, and I hope that we will explore those projects as well, like the Parser gem, the Ruby Parser gem, any number of other tools. Finally, I want to talk about very quickly compatibility with Ripper. Ripper provides three main interfaces: the Lexer, Ripper.lex, Ripper.s expression, and Ripper.s expression raw. We have one-to-one compatibility with Ripper Lex at the moment because that is the way we've run our test suite, but we're still working on compatibility with the parser. But the plan is to still build that in order to make it easier for projects to adopt, because I know that a lot of projects like RDoc and IRB are already using Ripper heavily. So we don't want to just yank the rug out from them. So hopefully there will be a compatibility layer that will allow them to migrate more easily. Finally, I'll talk about future work, what we have going on and what we have planned going forward. As I mentioned earlier, error tolerance is something you could spend an entire career working on. But one of the things that I really want to get in place is something called forward scanning. So in this case, this file has a syntax error in it, but it has some ambiguity. Is this actually baz.end, in which case we're missing an end keyword, or is it baz. Where we're missing the call message? In the case where you get into a point where you have this kind of ambiguity, one of the established practices, and the one I want to implement, is forward scanning, which involves scanning forward in the file and continuing to parse under a certain assumption, forking under each assumption until you get to a point, say 200 tokens forward, or until you hit the end of the file, and then counting the number of syntax errors making that assumption would have caused. And then you take the path that causes the least number of syntax errors. That's called forward scanning, and that has a lot of benefits because it allows the parser to quickly, without allocating anything, determine which path to take or which path to assume. Again, all of this is relatively arbitrary because we have to assume something. So hopefully this kind of error tolerance could yield some good paths forward. There's also future work to do in memory. Specifically, I'd like to create an arena allocator for the nodes to improve the locality and to keep them all relatively close. I'd like to reduce the overall size of the tree. At the moment, the AST nodes are not huge, but they're big enough to make me want to shrink them down. We're maintaining some extra metadata that we might not need to maintain. We're keeping some things around in 8-byte integers when we probably could use 4-byte integers, or just use offsets instead of, or length and instead of offsets, various things to reduce the size of the tree, and maybe introduce more nodes with more specializations, because right now we have something like one call node that has a bunch of null values on it when you don't have like a receiver. So we might want to introduce more specialization in that case. There's also some work to be done on the serializer to reduce the overall size of the serialized tree, potentially use variable length integers to reduce the overall size of the serialization. This has more to do with other languages using this as well. Going forward, I would love to have an entire rich ecosystem of tools built on top of this parser so that we could all benefit. And whenever a syntax change comes in, none of these people have to go and update their own respective parsers. They only have to implement it in their own language, which could be a really good path forward for Ruby tooling to be able to just inherently get the benefit of this new parser. So that is the status so far, and that is where we are at with the YARP project. Thank you so much for listening. I appreciate it. Once again, this is at github.com/shopify/yarp. If you have any questions or feel like contributing, feel free to talk to me on Twitter, or open up a discussion on the parser, or find me on the Ruby language Slack. Thank you so much.